we can start talking about Wi-Fi. So I've noted we're going to 802.11. And let's see, for the most part we're talking about B, which is oldest. We'll have G, which is sort of the middle grade. And then N and AC pretty much use the same technology, and they're the newest. All right? They all use unlicensed spectrum, and there's 2 bands you get to use. 2.4 gigahertz. Oops, I need to do a big G. So in the 2.4 gigahertz band, the way they set up Wi-Fi is they set up 3 separate channels that don't overlap. If you're setting up your Wi-Fi access point, you will have channel 1, channel 6, and channel 11. Right? And those don't overlap at all. What this means is, for example, at my house, I might pick channel 11. I want my neighbor then to pick, for example, channel 6. That way my signals don't interfere or don't get interfered by their signals. So our signals stay separated. Are we groovy with this? That's easy. Okay. If someone was across the street, for example, I might want them to be on channel 1. So when I'm setting up my access point, it makes sense for me to go up, into my house, check to see what my neighbors are broadcasting on, and try to pick a station that doesn't, or a channel that isn't going to interfere with their channel. All right? And again, like we said, each one of these has a certain bandwidth that determines your bits per second. Right? And those will vary too. With B, one of these channels would get you 11 megabits per second. With G, we got 54 megabits per second. And with N, you get about, and this depends a lot on a few other things, you get about 100 megabits per second. All right? Now, generally speaking, the band is the same size. So what we've done with each of these technologies is we've increased the signal to noise ratio. Either made the signal stronger in some way or made it better, the signal more visible above the noise that was out there. Right? So those are great. So I got 3 channels. Now, there's also the 5 gigahertz range. This is supported by N and AC, and there's a lot more channels up here. Okay? I'll just put, I don't know them all, I don't remember even the bandwidths anymore, but there's 10 or more channels in this range. Now in my house, I can go in and say, okay, why don't I use the channel, or the 5 gigahertz range, and if I check in the 5 gigahertz range, I actually don't see anyone. Now that seems really strange. Here's the thing that seems strange about it. I've told you guys already about my house. It has 3 levels. I put my access point in the basement. All right? Then I've got the first floor here, the second floor here. I do have an attic, but I never go up there. If I put the access point in the basement and I'm on my 2.4 gigahertz, I can go just fine up into the second floor. Okay? And in fact, on the second floor, I'm hearing my neighbors too, but I'm also hearing my basement. So when I do 2.4 gigahertz in my attic, I need to make sure I don't pick one of these stations, one of the channels that they're on. If, however, I decide I want to use 5 gigahertz, I do a separate network here, and so it might be called Haynes 5G. If I go into my second floor and open up my laptop, I told you I don't see anyone, so I don't see any of my neighbors. Not only that, I don't even see my own access point. Because at 5 gigahertz, the signal can't make it through all the plaster and everything in my house between the access point and my laptop.
Because of the higher frequency? Is that why?
Because of the higher frequency, yeah. So higher frequency. It's a higher frequency, so it's higher attenuation. Yes, there's more space. There's no one even up here, and so I can have lots Lots of bandwidth available. There's tons of bandwidth up here. In fact, they'll even let you, if you're on AC, you can bond some channels together. I think it has a 20 gigahertz or a 20 megahertz channel, and you can bond them easily into 40 megahertz channels. But there's lots of bandwidth available, and it's because it stinks. And just to note, there's right now the FCC is also allocated a 40 gigahertz. Okay, they call that ultra-wideband, ultra-wideband. And with this you can get, I mean, they're in a gigabits per second range, lots, or the 1 gigabit per second. But, and what do you think the but is here? So in my house, if I'm on the first floor, I can see the 5 gigahertz thing. The second floor I can't. Guess if I'm at 40 gigahertz, where am I going to see it? Just in the, basically in the same room. So here you have to be in the same room. It's very short distance. Okay? So ultra wideband, you don't want to be getting into that. All right? So that's fun. All right, one other thing to talk about, and that is bonding channels, or just using channels. I have an option up here. I've got channels 1, 6, and 11. And there was a little while when I was on 802.11g, you could buy a device that would do a thing called channel bonding. Okay? So I could take 6 and 1 and put them together. So I'd bond them together, and that equals a double the bit rate. Okay? And we saw that over here, right? You know, if I go from 200, if I get 300 kilobits per second at 200 hertz, if I double, so I can go to 400 kilohertz, I'm going to double my bit rate here. And so we're at 802.11g, we're running at 54. If I do a channel bonding, then I'm going to get 108 megabits per second. That's awesome. Okay? So why don't we do that? The thing we don't, or the reason why we don't do that is just really to be nice to our neighbors. So notice here, if I took 1 and 6, that means basically no one around me can be 1 or 6. I'm basically saying everyone has to be 11. But the funny thing is when you go to configure your base station or your access point, it doesn't like gray out. Have you guys ever configured one? It doesn't gray out the other options, or like someone's using that channel, you can't use it. No, they just get to pick. And so if I went in here and I pick a channel that overlaps with someone else, not only am I going to interfere with them, but they're going to interfere with me. So there's a trade-off. So within a spectrum range, there's a trade-off of the number of channels versus the bit rate of each channel. So I could have one huge channel that was all of my bit rate. So up here I could just use one giant channel, and if I'm at 54 or 100, that would be 300. I get 3 times as much. But that means only one person can be using this at a time. I'm also opening myself up to a lot of interference, right? So there's a trade-off here. Cell phone companies are doing this all the time. So they're trading off, they can have it set up with their spectrum so that they have a big channel that allows people to, say surf Netflix or whatever and do, really high bandwidth stuff. Or they can have a lot of smaller channels that maybe are good enough to do, pictures and, normal web surfing at that bit rate. So it's a trade-off. One customer running video versus 10 customers downloading pictures. So there's a nice little trade-off there. So that's kind of fun.